Very good evening, everybody. So, thank you so much for all the people skipping their weekends and attending this session. I can see that all of you are quite focused about your career and what is weekend, what is Saturday, what is Sunday, till you have achieved your goal. And to achieve your goal, we are also sitting here to, assist you or help you achieve that dream. All right. So, on that note, let's begin. So yesterday, a quick recap, we were discussing about machine learning in general, and we started discussing about unsupervised specifically. But while we were discussing about the unsupervised learning, we also, stumbled into the supervised learning because many times it is connected. You don't do one of them in a silo or in separate. The objective of doing an unsupervised oftentimes is to decide what supervised algorithm you'll do subsequently. So we will move to the we'll move to the supervised learning today, a little more deep dive into the various aspects. And we will start the questioning, which is the most fundamental question. I know 7, 8, 9 supervised learning algorithms. How to choose what? How is that decision taken? So that is the first question that I'd like to, address our panel today. And I'd like to, address it to Bernie first today. So, yeah, I'm just changing the order.
Yeah. So, thank you so much, Nitin, for asking this question. And this is extremely imperative step in the entire model building. Even before we get started with model building, one has to decide on certain parameters, such as, is performance or speed more important? Or is accuracy more important? Or is explainability more important? What is more important for the customer is a question that we need to ask first. And we also have to bear in mind on how much time would it take for training the model, because you will have to retrain the model or update the model as in how you have more data. So what is the frequency of updating the model? How much time does it take to train the model on the data? Because if it's going to take huge amount of time, then in stock market kind of scenario where you want your model to be updated on a daily basis, and say your model is taking 48 hours to complete the training, then it's not quite advisable, to have those kind of algorithms. So let me come back to the discussion point once again. Sorry to take a slight detour, because I wanted to give you the high level picture. First thing is accuracy. If the client says that for me, accuracy is more important, I don't mind about explainability or performance, speed. Then you might want to resort to deep learning algorithms, neural network algorithms. Neural network algorithms will learn complex patterns, huge variation in the data, heterogeneous data. If you have that kind of a data set, then neural network works very well, deep learning algorithms. However, one has to bear in mind that explainability will take a hit. You cannot explain the decisions that you are making, or you cannot explain the end result of your model. If someone says that, hey, there's 90% probability that you will default on the loan, then if that customer comes back to you and asks, why did you even reject the loan? You would not be in a position to do explanation. You will not be in a position to explain on what caused you to take a decision to reject the loan. At the same time, if a customer says that accuracy is more important for me, explainability is more important for me than the performance or the accuracy aspects, then one has to resort to decision tree, which is the best when it comes to building explainability into the model. Because the rules that decision tree generates can be explained even to an end user. And in those scenarios where regulatory bodies come into picture, especially life sciences, healthcare, or financial services, insurance, in these kind of scenarios, decision tree kind of algorithms are the de facto algorithms which are used. The next best when it comes to building explainability is regression-based algorithms. Right? So one has to bear in mind accuracy, one has to bear in mind performance, one has to bear in mind explainability. One also has to look into as in how we build the model. As in how you get new data or as in how the accuracy dips, you'll have to retrain the model. How much time does it take to retrain the model? So all these aspects have to be taken into consideration before you finalize upon which algorithm is the best, alongside giving importance to regulatory bodies. Yeah, thank you. Then.
Thank you, Bernie. Thank you. And thank you for that, prelude to the answer where you wanted to explain about why we go for the purpose for it. That those details were also quite welcome. So anything you would like to add, Sharath, to what has been just given by Bernie?
Just on top of what Mr. Bernie has said, he has covered everything almost, and very comprehensive answer. Just to add on top of that, I would always go back and look at the business problem. What is our objective? It starts right there. As we were discussing previously, as I was trying to answer the questions that were given yesterday, it all depends on the business objective and then the data, of course. So if our business objective says that it is a prediction problem that we have to resolve, obviously we will have to go for supervised learning algorithms. And when we go for supervised algorithms, if I have to put it in a flow diagram kind of a thing, the first thing is supervised. Yes, check. Then what is your target variable that you are trying to predict? And ultimately, we'll have to do prediction of a variable of interest that our business is requesting. So is that variable a qualitative variable or a quantitative variable? That's something that we will check. Then we look at whether if it is quantitative, whether it is a continuous or discrete data. And based on this, broadly, there are two classifications or two segmented ways to do the prediction. We can use classification techniques for predicting the non-numeric output, and we can predict numeric output, specifically if it is continuous, using regression techniques. So this is how we basically go. Once we get into this zone, then you'll again have variations. Like Mr. Bernie was saying, then we'll also have to put all these checklists, right? Time, accuracy, explainability, then how it can be tuned further. So all these becomes very pivotal as and how we start developing the algorithms. But always we'll start with the basic vanilla model, and we keep experimenting. And the experimentation duration is very, very critical because there's no end to it eventually. So it all depends on the time factor that you have as part of your contract with the client. Within that time frame, you also have to decide what all things you want to experiment, considering all these factors into picture. So that's basically how we can move forward.
Yeah. Thank you, Sharath. So again, this is a repetition which I keep doing almost every session of my, the takeaways from the answers that I get from the experts here. And that is your knowledge of the projects that you have worked on should be overflowing out of you in every question that you answer. Now, if you notice the way they have approached, both the experts here have approached it, is purely based on their experience, nothing to do with books, nothing to do with having gone through some videos or nothing like that. It's all based on that. And only if you have thoroughly worked with projects, 1, 2, 3, whatever maximum possible projects you can work on, will you be able to answer the way they have answered. And this is, sorry to use the word, this is a shut up answer. If you answer it this way, the interviewer has to keep quiet. He cannot ask a follow-up question. He has to ask a different question altogether. It's only when you give you're a little shaky in your responses, you say, yeah, we'll do this. Then he'll ask, why? Can you be more elaborate? So you'll have to choose, I call it, just now formulate the word, that your answer should be complete and nothing further. Let's move on to the next. So on similar lines, I'll move on to the next question. This question is this time for Sharath. We again changing the order. So Sharath, what is this lazy learner? And if it is lazy, why are we even learning about it? So can you just
Yeah, no. Yeah, like me, probably it is lazy. See, the point is,
I made a joke about what lazy learner, why you were learning. Sharath made an even bigger joke that he's lazy.
no, I'm truly. And see, the point is, when we try to bring up the patterns, ultimately all these algorithms that we are trying to use, basically to bring identify some hidden kind of a pattern which explains how your variable of interest is getting affected by the other factors. And there are many techniques as we were discussing, right? So one of these variations are called as shallow methods, right? Shallow techniques. We don't always have to go for statistical equations, right? Or heavy mathematical or statistical equations to try and grab the pattern. So we have this lazy learner, which is also famously called the KNN method, the nearest neighbor method, which it is a very simple distance-based algorithm, which looks at, hey, if you are close to me, that means you also have similar properties, right? So that kind of a algorithm. And this is one of the simplest algorithms. If you ask me, for my opinion, among all the different techniques that we have in the machine learning or data science world, KNN would be the easiest concept that anyone can learn, right? So it's that easy. And the problem is, it doesn't converge. I mean, it doesn't learn the patterns. It is a simple distance-based logic. And it is called as lazy because of that, right? It's not able to identify the pattern in the first place. And yeah, the problem is that it is simple distance based. And I mean, you I don't know how to explain these points. If you see, it's called as lazy for a reason, that it doesn't have too much of mathematical or right statistical rigmaroles that we have to really worry about. Simple distance based, right? So
Yeah. All right. So before we proceed any further, we have a question from one of the participants. I think before also we've used the word vanilla model, and I think we've assumed that people will understand that. So yeah, would any of you want to take it up and explain it? Barney, maybe you can explain what vanilla means in this context, and also answer the question about the lazy learner, your inputs on that.
Sure, absolutely, Nathan. So, yep. So vanilla model usually means you use the model with all the default hyperparameters. That means if you just say KNN and give your inputs and outputs within the code of the Python, then it would select all the hyperparameters, but all these hyperparameters would be default values. Okay, so if you end up using default values or default hyperparameters or attributes within your model, then it's called as a vanilla model. That's a regular term that we use. Okay, going back to our lazy learning concept, right? Students usually, including me and a lot of people, are lazy. That's called as student syndrome. What do you mean by lazy? You will upfront at the start of the course or at the start of your academics, you'll decide that, hey, I need to, on a daily basis, study for the exam. I need to prepare very well and get above 90%. But eventually what will happen? The fire will die down because you know that the exam will be after 1 year or after 6 months. Then you will eventually feel that, okay, 1 week before I will sit down in a very, disciplined manner. I'm going to go through the entire syllabus. I have to get 80%. but eventually that also would not happen. Until you know that tomorrow is the exam, that seriousness doesn't creep in, right? And the students become lazy. And KNN works exactly in a similar fashion, wherein until there is a new data point, until you need to do a prediction for that, given a new data point, meaning given the age, gender, income, interest amount, loan amount, etc., you have to classify whether that person will default on the loan or not. Until you get that, the algorithm doesn't work. Only once you get the new data point, from this new data point, you calculate the distance to all of your training data points and then decide whether a person will default or not. So you wait until the last moment, you wait until you get the new data point, only then your algorithm will kick off. And hence it is also called as non-parametric. There are a lot of algorithms which will run on the training data. It will formulate a math equation and keep it handy for you. And the moment you have the new data, you need not retrain on the training data. You just pass it through the math equation and then you get the result. Whereas in KNN, until and unless you calculate the distance from this new point to all of your training data points, you would not be in a position to predict the output. This is the prime reason why KNN is called as lazy learner.
So I my take for the lazy learner is I would rather say it is a dumb model rather than lazy learner, that it is doing the same process multiple times and not remembering anything, doing the entire thing again. So I would prefer to call it that way. If you have 100 test records, for every test record, it is going through the entire training data, understanding the distance metric. Then second test record, when it is coming to that, again, the entire process, it goes on till the 100th. It learns nothing. I mean, what did you learn? When you touch fire, the first time you learn, don't touch fire. But this model is so dumb, it doesn't do it. All right. So that is the way I kind of explain what lazy learning is. Thank you, Barney and Sharat, for the insights there. On that note, we'll continue a little bit more about the lazy learning itself. All right. So we have predominantly the Bayesian classifier and the KNN, and also to a certain extent the decision tree. Again, me and Sharat argue on that, but okay. So we'll discuss about the Bayesian classifier, and I would try to understand what are the limitations of the Bayesian classifier. Again, Sharat, you can go first, please. Why is it not very popular?
I would not say it is not popular. I would not agree on that terminology. I mean, that statement. It is quite popular, and the algorithm itself is depending on the Bayesian rule, right? Knight Bayes, and this is something everybody learns in their primary, or I should say, their academics, right? Probably their 9th grades, 10th grades, around that. So it becomes very, very pivotal, very, very important algorithm. And it is purely based on the probability and likelihood. In other words, I would also call it as a conditional probability. The challenge would become if you have too many factors, extracting the dependency kind of gets calculation heavy. And it also has the zero probability challenge. Especially because if you're training data and test data, that means you have a new data that it's coming in. If it doesn't have a factor that you already have, all right, then obviously it may not be able to tell you what is the probability. So it purely depends on the historical data, right, and it doesn't learn anything new when new data comes in. So we get kind of a zero probability problem, and that is one gray area here. And of course, we will have something called as Laplacian smoothing to counter that, but that's a different point altogether. So to answer your question, yes, Knight Bayes is not, from me at least, it's not unpopular. It's kind of a popular algorithm. and it is purely based on probability and likelihood.
Okay, so like I said before also, till the foundation levels are there with reference to statistics, with reference to interpretation, with reference to pre-processing, I think the world is in agreement with each other. We three are data scientists, and we've worked together in the same company, and we don't agree on certain things, all right? So that is the beauty of the machine learning models. Generally speaking, right? Somebody says this is better because of the experiences they have had with that particular, that particular aspect. So yeah, that is essentially the thing that I wanted to, provoke the people on that and try to get their perspective on that. So yeah, Barney, your take on knife base and its usefulness or lack of usefulness, whatever stand you decide to take.
Okay, sure. Even gods have feet of clay. Given this context, no algorithm is foolproof. You will have its strengths and weaknesses. You will have the pros and cons. You will have to judiciously pick up the right algorithm and start using that. And a few of the strengths with respect to knife-based algorithm is that it works very well when you have textual data. And when you have textual data, and then you have a classification model as well. For example, you have the emails. On Gmail, you keep getting emails. Those emails should be basically classified as spam or social or promotional or going to inbox. When you have this kind of scenario, knife-based works very well. So given the text data, when you want to pre-process that and when you want to apply a prediction model technique on that. However, it has its flip side as well. And the flip side is that it expects the features to be independent of one another. Probability. Okay. When you do that calculation, it expects the features to be independent of one another, and that's not the case. In most scenarios, your features that you have would be dependent on one another. You cannot have features which are completely independent of one another. And second disadvantage is that it doesn't work well if you have large number of numerical features. Given that, once again, you need to calculate the Bayesian probability. By applying your Bayes rule, you need to calculate the probability. Given that if you have numerical data, large number of those features, it doesn't work well. Right? So these are the disadvantages and advantages. But once again, as I've told you, it's all about experimenting. For what kind of data, what kind of algorithm really works well, we cannot say upfront. Not me, not anyone, even God cannot say with confidence that this algorithm will work on this data set, apply that, right? So we have to experiment, and only then can you figure out. And we all are lucky, right? Because it's not as difficult as doing your education. In education, you do your BTech in mechanical, BTech in civil, BTech in electrical, BTech in electronics, BTech in computer science, then decide which suits you. You cannot really do that kind of experimentation when it comes to your education. But when it comes to machine learning algorithms, you always have the provision to experiment. Yeah, thank you.
Yeah, adding a little more on that on a humorous note, it's a good thing that we don't have a very rigid mapping for this data, this model, this data, this model. Because if we did, I think this interview session would have been redundant. All right, we wouldn't have anything. You have somebody would have created the cheat sheet. You pick it up, okay, this data, take this model, done it, you are done, the job is done. It is because that there is opportunities for improvement. The best of the best data scientists will give something. You can take that and work and make something even better, is what creates the opportunities for data scientists and the demand that is very much there. So that is another take on that. So yeah, we will agree to disagree on which is the best. We will continue to agree to disagree on which is the best model. Thank you so much for that insight there, both of you, Barney and Sharath. So let us go back to the decision tree, and we'll restrict our discussion to only decision tree. We just have a couple of minutes. I will give it to Barney to speak about it. So in your opinion, not going into the ensemble techniques or random forest, how best have you managed to squeeze or change the levers and improve the accuracy and explainability of decision tree, in your opinion?
Okay. Yeah. So number one point is that decision tree has explainability inbuilt into that. So even for a layperson, the moment they look at the rules, it will say that, okay, the new customer is applied for the loan if the age is less than 30 years, if that person is female, if that person is a postgraduate, if that person's income is greater than $10,000, that person will not default. In that way, rules will be, popped out of decision tree algorithm. So even for a layperson, it would be very clear. Even from a business user standpoint, it makes a lot of sense. Point two is decision tree is also used for feature selection. So if you have, huge laundry list of inputs or features, then you can shortlist the key features from that by looking at information gain, which would give you how much information is contained in each and every variable. So alongside having the explainability, decision tree also has a capability to help you shortlist the important features. Right. So, and we have a series which is planned in the subsequent weeks, wherein we are going to pick up each algorithm and we'll delve deeper into that. And the third point is that I think decision tree is a next algorithm or the algorithm next to neural network, which has a huge number of hyperparameters. And people would ask questions, in an extensive manner in interviews when it comes to hyperparameters within decision trees. You'll have pre-pruning, post-pruning, you'll have a lot of other techniques, and you'll have a lot of hyperparameters in that. One has to be aware of what does each parameter do and what is the default value of each parameter. Right. So, yep. So these are a few points that I wanted to bring to light, Nitin.
Yeah, thank you, Bernie, and pretty concise and at the same time informative information you've given about, excuse me, the decision tree and how enormous or how big it can be, and it can give explanations to that. So wrapping up and continuing on the same vein, on the same tone. All right. As you gain more and more experience now, even the many students when they do the project, this is of course with a little bit of regret that I'm saying this, but many students when they do the projects, they take up one, maybe two algorithms. They will try to keep, beating the horse. You have one horse, you keep whipping the horse to run fast. What you should ideally do is remove the horse, put a donkey. Maybe the donkey will run faster in that scenario. Remove that and put maybe a bullock, because the road is very rocky. You need a bullock. A horse running fast doesn't help. People don't realize that. And only if you try, you don't need multiple projects to get that kind of exposure. You just need one project. Try just about everything, which, sorry to say, with little bit of regret that it is about lacking in quite of the projects that I've seen. They just pick one and keep squeezing, keep tuning the hyperparameters to get the best fit. So that is one takeaway. And that is the reason, that is when you will have these kind of arguments. All right. And on that note, I'll, wrap it up for today. Before we go, a warm wishes for a safe and happy Diwali to all the people. Some are celebrating on Sunday night, some Sunday, midnight Sunday, Monday, some are celebrating Monday evening. But whatever it is, have a safe Diwali, everybody. And And we expect you to continue to support us by subscribing and sending out the word to your friends that this is this opportunity and you can connect with us. So this is, with this note, thank you so much.
Yeah.
Thank you.
Thank you,
Bye.
everyone.
Happy Diwali.